Welcome everyone again. That's the second video. As a preview from SP1, for SP1, as I promised, today we are talking about the electrical system. What I want to talk about here is the electrical system, just generic, and then focusing on what we modified for SP1. As you can see, everything is turned off, complete content are copied, and we can actually start up the battery first. As you can see, battery can be turned on is indicated, and if you go in the main panel, you can see actually that in the main panel everything is turned off. We just have the two clocks actually coming up. The artificial horizon and standby instrument are working, but nothing else is actually working because we don't have any AC power that is the main source for the vast majority of services into the aircraft. So we can actually turn off to the standby power, and the standby power is powering the AC buses from the DC power of the batteries, of course. And this is quite this will turn on the left hand side of the aircraft. Left hand side, I mean the PFD and ND for the captain, the upper DU and the left CDU. All the rest needs to be powered from the right hand side or from the APU or the ground power, and I will show you that happening. So as I told you, just get standby power to auto. As you can see now, all the services and the lights are coming up nicely. This means the aircraft is now powered on the left hand side and on the main services and lights. And if we can, for example, go to the main panel, you see now left CDU is working. The left hand side screens will turn on in a few seconds because that's a realistic DU startup process. They need to warm up, and so they need some few seconds to actually come up immediately. Anyway, we can actually set the bus tie to automatic in few seconds. I will switch the ECAS to the inbound CRT, so we can actually have a look to the pages from the ECAS there, and I will just prepare the CDU and the CMC to show you more things from the SP1 and what we change for SP1. What I will show you will be actually what we changed for the generator and actually what we modified as electrical power. What has been done on the electrical system is quite interesting. We kept the realistic electrical discharge from the FS core, at least for FS9, and this will show you that the main battery always discharge even with ground power and APU. This is mainly because ground power and APU are not modeled in the FS core. FS9 doesn't recognize those two types of modeling, so if you have SOIP, you can actually use the battery fix and make infinity battery, and this works perfectly with the iFly, just in case. Anyway, we will switch the ECAS to the electric page, and as you can see now, electric page on the left hand side, bus tie all isolated. Just imagine now turning on the bus tie, and I will show you the check. You can see bus tie isolated. We can set all of them in auto, and now we have everything in auto. As you can see from here, they don't show isolated anymore. Anyway, everything is in yellow because we don't have any AC power from the aircraft, from the generator, sorry, and from the external power or APU. We connected the external power earlier, and you will see that if we go to the ECAS maintenance page that show more values, you will see main battery 28 volts, keeping APU battery is not showing anything because it's of course not being used at the moment because the APU is not being started. For this reason, APU battery is showing 0, and then external power and APU are connected but not showing anything. For example, we can now set up and turn on the external power, and I will show you various values being shown here. As you can see, external power 1 and 2 available. This means frequency and voltage are matching the one from the aircraft system, and so we can just press and you will see the horn bar being shown on the bar. Now coming back to the electrical CMC page, you will see external 1 and 2, 115 volts, 400 frequency, and the load is now 0.65, means 65% of the maximum possible load on the external power. And of course, this load can increase, decrease, depending on which services are being used by the aircraft. At this point, we can actually think about turning on the APU, so we can start the APU and wait for the generators to come on. At the same time, I will just show you, while waiting the APU for starting, the various functionality of the various switches. Utility bus is actually galley power and aircraft electric power. Just turning on the left hand one and just coming back to the ECAS. And you can see now on the main ECAS you will see external 1 and 2 are actually connected. All the bus 1, 2, 3, 4, AC bus 1, 2, 3, 4 are powered. Of course generators are off. And then you can see utility and galley on the left hand side are powered, and they can be seen by the green, and they are yellow on the right because of course they are not powered from the right. So we can now turn on utility for both and then wait for the APU to start. As you can see now we have generator is available for both APU buses. External power is on, and so we can select APU generator 1 on, APU generator 2 on. Well, we can try keep the external power and I will show you what happens. Utility switch 1 and left and right both to on position, and generator control on just for later startup of the engines. Okay, as you can see now we have the APU generator 1 on the left hand side of the aircraft, external power 2 on the right hand side of the aircraft, powering the bus 3 and 4 AC buses. Generator controls are still off because they are opened just when the generator reached enough speed after startup. And as you can see the SSB bus tie is open because we're using two different sources, so this is actually dividing the system into complete separate systems. So bus 1 and 2, AC bus 1 and 2 powered by APU, AC bus 3 and 4 operated by external power 2. We will now set up APU both the sides of the aircraft on APU generators and then coming back on the main panel. Okay, so we can select APU generator 2 and it's on and coming back. Okay, finally APU 1 and 2 are on. We can display electrical ECAS display page. As you can see now we have just APU 1 and APU 2 connected. 105 volts, 400 Hz as a frequency, and we have a load of 73%. That is different from the one of external power before. That was around 65% for both sides, of course, because the load possible in APU and external GPU units is different, so we are simulating that. As you can see now, APU battery is now showing the voltage. That's because the APU battery is now being used, or anyway harmed for the usage by the APU. And what I will do now is turning on the engines and showing you how the generators actually are being turned on, and they actually get new values, more realistic, with the SP1. We are now starting the engines, the number 4 and 3, as you can see on the upper ECAS is an auto start, so we leave the system going on. And what I want to show you is that when the engine fires and when you see the EGT rising like now, the EGT rises but the generator doesn't come online immediately. Why? Because the generators in a modern aircraft or modern jetliner need some speed to actually be able to give you enough voltage and the correct frequency to power the system. So as you can see, the engine started, there were two alerts to caution that was actually about the generators for engine 4 and 3, and now that the engine is started and stabilized on 24%, the two generators went online, bus 3, bus 4 connected by the generator. If we now start the other two engines, also the other two generators will come online, and if we go to the CMC page, you will see now that the two generators online, number 3 and number 4, APU 2 is now disconnected, and the left hand side of the aircraft divided by the SSD is now powered by APU 1. As you can see, the voltage, the frequency and the loads are actually changing time to time. This is more realistic because what happens with these generators, they have a constant speed unit. This unit, well, that's the simple version anyway. A CSU, or constant speed unit, provides a constant frequency and voltage coming out from the generator. So this CSU keeps 395 to 405 Hz that are actually normal margin for an aircraft generator, and they are actually checking also the load of the aircraft being manageable below 100%. As you can see now is 84-85% around. And now we will start the other two engines and come back talking about that. As you can see now, engine starting, generators coming almost on, 2 and 1 off, and when they will come online you will see the SSB closing, of course. And SSB is now closed. Why? 4 generators gives you the same frequency, and because of the CSU and the voltage being maintained the same, they can be actually parallel to make it possible to actually have a generator on engine 4 to power the services in bus 1. This is quite a nice backup system for an aircraft with 4 engine that is quite different from aircraft with less engines like 2 and modern ETOPS aircraft. This means actually you can actually use every single generator to power any service into the aircraft, and SSB by the logic, so automatically is being closed by the 7.4. Okay, at this point we have actually turned off the APU, connected all the 4 generators, and we are in a normal situation after the engine start. In this situation we can actually see a few things that have been changed from the hotfix. At this point we see values are more realistic on all the 4 generators. They change depending on the load, on the engine parameters, rotation speed, and of course the CSU. When the engine change the speed, of course, when you are actually pulling up or pulling down the engines, those values are more prone to change, because of course there is more work being done by the CSU, just speeding up the engine, speeding down the engine depending on what are they needed for the system. As you can see now, we have voltage, amperes coming out from every generator, 25, IDG temperature, and rise temperature, of course, for the integrated drive generators. At this point, you can see the load, and this is one thing that we modify for SP1. It is quite interesting, differently from what we were doing, what was being done with the hotfix. As you can see now, we have 4 generators on, all of them sharing a quite similar amount of load, 74%, 75%, and changing. This is because being parallel, they are sharing the load. So if generator 4 is maintaining 74%, there is a feedback loop that actually makes possible to maintain the same quantity of load on the other generators. Now, if we turn off a generator or 2 generators, some things happen. Just for example, let's go on the overhead and try to turn off a pair of generators. Okay, just imagine turning off 2 generators, just as an example of a failure. Let's say we have left hand side, right hand side, so we turn off generator 2 and generator 3. We come back to the main panel, and as you can see from the CMC page that show all the values, like generator 2 and 3 off. Generator 2 and 3 not showing any voltage, not showing anything coming out. Generator 1 and 4 working perfectly. What happens on generator 1 and 4 is that their load is around 100%, just slightly less than 100%. This happens because we have an SSB that divides the system between 1, 2, and 3 and 4. If we go on the electric page on the ECAS, you can easily see 2 generators are off, other 2 are working, and the generator 1 and 4 are powering all the 4 buses. If the SSB fails, for example, we must have 1 generator for each side to be able to power all the loads on both the buses present on their side. So if bus generator 2 fails and SSB fails too, for example, or opens, because the 2 speeds of the generator are different, or there's another specific reason for that, generator 1 must be able to actually power all the load on bus 1 and 2 without overloading. So it means below 100%, less than over 100%. So in case 100% will be fine, 99% will be fine, because it's able to power all the systems. If you go back to the CMC page now, you can see the load here is 100%. It never goes over 100. It's around 99%, 98%, and is doing its maximum work as a generator only. What happens if the aircraft has only one generator working? Well, let's discover it. At this point, generator 2 and 3 failed, and for example, engine 4 fails again. So we have to turn off the generator control number 4, or the generator control number 1. In this case, we just use generator control number 1 to comes off, and you will see what happens to the other generator. We now have just generator 4 powered. As you can see, 1, 2, 3 are off. And the load now is showing more than 100%, it's 110%. This means the generator is being overloaded, and if the generator is left in this condition without load shedding means actually turning off services, just like secondary pumps or lights that are not being used. Without load shedding, this generator will fail in some time, and we will left without any power, electrical power on the aircraft. If, for example, I will just show you what happens if you just overload the generator in the case of an iFly. we're back to a situation with all the 4 generators working. Now imagine having just generator 3 working, just like generator 4 fails, generator 2 fails, generator 1 fails, and go back to the CMC. What you can see now is generator 1, 2 and 4 failed, and generator 3 is not showing any voltage because overloaded 110%, it just lost all its working capability, and it so lost all the voltage, and so is not powering anymore the aircraft system because it's of course overloaded. And this is one of the new features of the iFly together with the realistic values. If we go up and actually set all the 4 generators back to on, okay, now we select all the generators back on, back to the main ACAS, and here we go, our system fully working, fully perfectly ready to go and to fly. That was an overview about the electrical system. Hopefully it was not too long for you to follow me during this presentation. I want to show you some more systems. There are some big changes, some smaller changes in other systems. Next system will be probably it will be another decision between hydraulic and environmental control system, or pressurization and air conditioning. This is because ECS differences are quite longer to explain, so I will decide which video I can do, and then I will post it again. Keep tuned, keep prepared for SP1 to come, and I hope you enjoy the flight. See you soon in the forum, and of course on the next video in the next few days. Thank you very much.